Hello students, it's not lesser physics classes. I have come up with new challenging problem for you from electrodynamics. The problem is here is a coil, inductance coil, and this inductance coil has 200 turns and the area of each turn is 100 centimeters square. And there's a magnetic field inside the coil, but this magnetic field is not due to the current in the coil. It is an external magnetic field. ये जो field है ये external है, and this passes through the turns of the coil. And this field is constant, and as such there is no current in the circuit, because so far as the field is constant, flux is constant, there is no current or no induced EMF in the coil. Now this magnetic field is reversed. I mean, it is flipped over in the downward direction in 0.1 seconds. The field was in the upward direction 1.1 Tesla. It is reversed in the now it is created in the downward direction with the same magnitude. We have to find how much current passes through the resistor during that time period 0.1 seconds. That is our question. The coil with these many turns, area of each turn is 100 centimeters square, and the magnetic field is external in the upward direction through the coil. The magnetic field gets reversed in 0.1 seconds, and we have to see what is the induced current in the circuit during this current 0.1 seconds. You must be knowing when there is a coil and the magnetic field is through the coil. If the magnetic field changes through that coil, there is an induced EMF in the coil to keep the current constant at that moment, because there is an inertia, it is an electromagnetic inertia. If there is some kind of flux through the coil, एक coil है, इसमें इसके through flux है, इसमें through इसके इस coil के through field है, flux through each turn of the coil. If you try to change the flux, the induced EMF will try to keep the flux constant. The induced current will be such as to keep that flux constant at that time. So there will be a resistance, there will be a reaction from the coil itself to keep that flux constant. So whenever you try to change the flux through any coil, there is induced EMF which opposes that change. If that change is to decrease the flux, the induced current will be to keep the flux constant, and it will try to increase the flux to the original value. So that is called an electromagnetic inertia. It is simply the reaction. Whenever there is a change in magnetic flux through any coil, the induced EMF or the induced current will be such as to keep that flux constant. That is the base rule, that is the basic concept. Okay, now is the flux in this direction, in the upward direction. When this flux changes and gets reversed, the induced EMF and the current in the circuit will be such as to keep this flux constant in the upward direction at that moment. Therefore, the induced current will be produced in the circuit so that this flux will tend to remain in this constant in the same direction. So how much is the current? What is the rule? The rule is, first of all, let's find the change in flux. Let's find the change in flux. Okay, phi 1 solution. Phi 1 initial flux, that is NBA, number of turns of the coil, magnetic field, and this area of each turn, that is NBA. Okay, now what is final flux when it gets reversed in the downward direction? That will be minus NBA again, because magnitude of magnetic field is the same, 1.1 Tesla, but the magnetic field gets reversed. It becomes downwards, externally. Okay. What is the time interval? That is 0.1 second. What is change in magnetic flux, delta phi? That is phi 2 minus phi 1. That is minus NBA. That is phi 2. That is minus NBA. What is the change in flux? Let me solve it out. Minus twice NBA. Now, what is induced EMF in the coil due to this change in magnetic flux? There is an induced EMF, a kind of voltage, a kind of potential difference in electrodynamics, which will produce the current later on because the circuit is closed. Now, what is induced EMF? That is E, induced EMF, that is minus delta phi by delta t, that is minus delta phi is 2nBA by delta t, that is induced EMF is equal to, that is negative, but this is also negative, that is 2nBA by delta t. This is the induced EMF produced in the circuit. Now, this is the induced EMF, means a kind of potential difference is produced within this coil, and that will send the current through the resistor. And what is that current in the resistor? How much current is produced in the resistor? How much current is produced in the resistor? The current produced in the resistor is, the current produced in the resistor, that is current is equal to, produced in the resistor, that is induced EMF by R, resistance, that is current is equal to, that is 2 times nBA by delta t whole divided by R, but that can be written here, R, that's 2, n is number of turns, that's 200, B is 0.1, and area is 100 into 10 raised to power minus 4, because of this centimeter square has to be converted into meter square, divided by, because everything has to be converted into SI system of units, divided by 0.1 into resistance is 5 ohms. Okay, now current is equal to, that is 2020, and this will cancel out, this is 2, this is 4.1, this 4 by 5. And magnetic field, where is the magnetic field? Magnetic field here is 1.1, sorry, it's 1.1, and it will be 4.4 divided by 5, that is 8.4 into 0.1, that will be 44 by 5, that is 8.8 amperes. That is the answer. So the base question was, there is an inductance coil through which an external magnetic field passes. That external magnetic field gets reversed. When that gets reversed, the flux through the coil, the inductance coil changes. When that flux changes, that will produce induced EMF. That induced EMF will send current. This is because the induced current will try to keep the flux constant during that time, and that reaction is responsible for creating the current in this circuit. So this is the answer to this question. So please continue to watch lectures on YouTube, Tantra Physics classes. I'll be continuously delivering lectures on different fields of physics so that you prepare for the exams. Thank you.